Let's start by looking at selection pushdown, which we said is a heuristic that we want to use in all cases. So here we're going to take the rating selection and we're going to push it down through the join to the sailors table because it's a predicate only on sailors and we can apply it as early as the scan of sailors here. So let's see how this affects our costs. Well, we're going to scan sailors, so that's 500 IOs. And then for each page full of high-rated sailors, so not for all the sailors, just the sailors that have a high rating, those are the ones that we're going to put into pages for page nested loops join. So for each page full of those high-rated sailors, we scan reserves. So it's 500 plus some number of times of a scan of reserves, which is 1,000. So how many times will we scan reserves? Well, we assumed that ratings were evenly distributed across the sailors, which means that rating greater than 5 is about half the sailors, because the ratings went from 0 to 10. So the total here would be 500 plus half of 500, which is 250, times 1,000. All right, and looking at the cost for that, it's approximately half of the cost we had before, more or less. And so this is clearly a better plan. It's only 250,500 IOs. So it's a good heuristic in this case and in most cases. Now what about pushing the selection down to the other side? Let's do that too. So the selection on reserves, boat ID equals 100, can indeed be pushed down to the right-hand side. And let's see how this affects the cost of this query plan. So to estimate the cost, think about it this way. We're going to scan sailors one time. And for each page full of high-rated sailors, what are we going to do? We're going to go to the right-hand side of this join, which is going to scan reserves and filter things based on BID equals 100. That filtering happens on the fly, which means that for each scan of reserves, it will reduce tuples, but we're still doing the scan. So for every page full of high-rated sailors, we are still scanning reserves, although we're throwing away tuples as we scan. So the total number of IOs is actually 500 to scan sailors, and then 250 times scanning reserves and throwing away BID not equals 100 as we go. But we're still paying for that scan of reserves every pass. In essence, when you push a selection to the right-hand side of a nested loops join, it doesn't save IOs, because the selection's happening on the fly after the IO pass of reserves each time we loop through it. So this is essentially equivalent from a cost perspective to having the selection up above. It makes no difference in the cost. So the decision here might be to push it down or to not push it down. They're equivalent.